It's something that I've always wanted to create here. We have such a great campus. I really wanted our students to be able to leave a legacy of themselves, and there's such great new discoveries going on in our solar system and in the universe that I wanted them to be able to share it with others.
Where does outer space end? It's sort of hard to
We're trying to make a scale model of the solar system on our campus.
After leaving the National Air and Space Museum, we walked and observed the outdoor scale model.
How many steps?
Jupiter gets
This
bigger.
is the planet Jupiter and its 4 largest moons at 10 billion actual size.
Jupiter is
Callisto,
bigger.
Hello, Europa.
This is an example of one of the plaques displayed in Washington of our sun. The plaques displayed a scale model, information about the planet, and how far the planet was from the sun.
As you go on, they get farther away from each other.
Why do you think that is?
These are the inner planets and the ones outside of the asteroid belt or the outer planets.
I learned that Pluto is the coldest planet in our solar system.
I learned that Saturn's density is 7/10, which means it could flow in Georgia.
Happy New Year.
I learned that Venus is the driest and hottest planet, and it's negative 470 degrees Celsius.
I had learned about the outline in the planet because it was real interesting for real, especially the big old scale layout. That's what I learned.
I am enthusiastic about my science, okay? I really enjoy it, all right? And if I have to be enthusiastic and get you giggling at me to get you interested, I will do it, okay? All right. In science, we find that we can just look at numbers, but we can also look at graphs and gain a little more information. The numbers are sort of the math of it, and the graphs are the visual tools of it. All right, hold them up to the light. Look through both pieces of paper. Tell me what you see. Do the patterns match up?
Yes.
All right, how well do they match up?
Very well.
Huh? The grids aren't the same. All right, hey, did you hear that? Oh. Leo made an observation. The grids aren't the same, okay? All right, they don't have to be the same as long as they're relatively scaled okay. The point is that the distribution of radius and the distribution of mass follow similar patterns. What can we conclude from that? Okay, who was I up to? Nicole, what does that tell you?
So you get the same, the way you rank on one grade, going to rank the same on another.
Exactly! Fantastic. She said the way you rank on one graph is going to be the same way you rank on the other graph. We call this in science a correlation. Okay, we're going to use a simpler word called relationship. There is a relationship between mass and size. Then we have the asteroids. They are made of?
Comets and
asteroids. Asteroids are made of, what's their composition? Rock and some ice. The gas giant planets are made of? Yes. The Kuiper belt is made of?
Ice and some rock.
And the Oort cloud is basically the same as the Kuiper belt, so it would also be ice and some rock. We have discovered so many new things about the solar system that you're going to be able to go home today and teach your parents.
We were learning about the solar system, and we had the opportunity to work with the Science Telescope Space Institute, and they taught us about everything that's going on in science, and it's saying that Pluto is not really a planet, so we're going to use that knowledge to put towards our project.
The solar system has two groups of planets. One, the four moderately sized inner planets, Mercury, Venus, Earth, and Mars, which are made of metal and rock. And two, the four giant gaseous outer planets, Jupiter, Saturn, Uranus, and Neptune. Pluto doesn't fit in either of those categories.
We don't exactly know if there's 8 or 9 planets, because there can be more planets in the solar system than what we know.
The solar system is messy, and the bodies of all sizes flying around in many orbits, so it could be anything. It could be a Kuiper Belt object, it could be a planet, so we don't know the exact meaning of what a planet is. They don't have any exact definition of what a planet should be.
But if Pluto was discovered today, it might not be called a planet.
Well, okay, that's today.
I think that Pluto should be a mini planet because I think that it doesn't really fit in either category. And also, it's like, what is a Kuiper Belt? Is it like a group of objects, or is there actually like a place where it ends? Because the way Pluto and the Neptune switch places, if they switch places, does that mean Neptune's moving into the Kuiper Belt? And then would Neptune have to be considered a Kuiper Belt object too?
Pluto is considered a planet. That's why it said that Neptune becomes the 9th planet.
So then they're kind of moving out of the Kuiper Belt, and then it's not really an error. They're just objects who are around places. So it seems to me like they're just trying to fit things into an area, and if they're moving in and out, then it's really not a Kuiper Belt, and then you can't really put Pluto in that category either, and that's why it should be a mini planet.
Pluto has been a planet for so long, for 66 years, and why change it now?
I mean, you wouldn't want a 66-year-old car. You would want a new version of it, so we keep getting better and better.
As a part of being a leader of my group, we are trying to talk to Mr. Bond, who is the big boss of this. We're trying to talk to Mr. Bond to get him to give us a list of organizations so we can get some grants, meaning some money, in order for the plaques to be displayed in our campus.
What I encourage you all to do is think about how you make a strong case statement for why someone would want to give money to this project. How is it going to help you better your life, and how is it going to help your fellow students, and how is it going to help your community or your family? Those are the kind of things that a funder wants to know.
I consider these first drafts because this is the first time that you wrote these paragraphs, right? You wrote an original first draft, took it to Mr. Bond, some of you, he gave you some feedback, you kind of came back and you sort of rethought what this letter should contain. So this is kind of the rough draft. It's important that you have good ideas, it's important that your ideas are organized, it's important that you pick powerful words, it's important that your voice comes through, it's important that your sentences flow, it's important that your writing is free from mistakes with grammar and spelling and punctuation.
Our letters aren't due, really we don't have a deadline for it because it takes a long time process, but our goal is to have it done by, the project done by at least April, because there's the conference going on, the teacher conference where they come from different states going on here, and we wanted them to be able to see it.
One interesting fact about the planet, comparing text to life connections, for example, like Jupiter's diameter is like 15 times the size as the World Trade Center.
I'm drawing the flag for the scale model.
All of these titles are different. They're all written differently, and I wonder if really high-quality plaques have titles that all look different, or if there are some consistency among them. So think about those things as you're looking.
Well, right now we are critiquing the others group 8-1 layout that they did for the plaques. And now we just like giving them feedback on what we think of the layout.
I think that the plaques so far are very boring, and it's just like plain ordinary information that everyone already knows. Well, they probably don't already know it, but it's like they need to put something more exciting on there and make it more, you know, put a little spice.
The plaques are different from ours because they're not as high quality as ours was, and the outline, like the border of the plaques, or just plain like any other plaque that you would see, and they don't have as much pictures as we did or information on that plaques.
I think they could make it more unique in a different way.
Observation was that the planets from Mercury to Mars was wrong size.
Why is it there? That's a really great thoughtful one.
Comment made by Katie.
Comment made by Katie.
She wrote in different colors.
What? Yes. You think it's better than what you expected? No. Or it's different?
I like a couple of them better than I expected. One was Alfred House and the style design. I like that. I think you can use a little bit of that style right there.
Well, that's the point of this too. It's for you guys to get ideas. We learn from each other. So you can be getting ideas of what you can use in your class. We take what you liked and make it even better. Wayne. What else?
I don't see no R.
I think they have all that pictures.
So incomplete?
Group Iron Man is the survey team, and the survey team you gotta have good math abilities.
When measuring the canvas, we know where everything will go at. Because we have to make a scale so that it actually look like it's the real solar system. So once we measure the path, we're going to come up with a scale so that all of the planets and objects in the solar system will fit on our scale model.
We use feet. Right now we got 301 feet from up there to right here. Because we messed up some calculations. That's what scientists do.
1.35 feet.
But we're doing it over, so. That's the end of the rope, so we gotta start from right here and do the rest of it.
Once we give our sketches to the Fresh Start people, they know where to put the posters in the ground for our plaque.
I always think that hands-on helps students learn better. It gives them a sense of purpose and a sense of excitement that I don't see when we're learning out of a textbook. And they're not just reading the information or having me tell them the information, they're actually discovering it themselves.